Okay, Jenna flips 2 coins. The possible results are shown in the diagram. What can Jenna get? If she flips 2 coins, what can she get?
Heads or tails? Or tails, tails, heads, tails. Heads, heads.
Tails, tails, heads, heads.
Heads, tails.
Heads, tails, and tails, heads. So how many different options is that? 4. According to the combinations here, I can have heads, heads. I can have heads, tails. I can have tails, heads. And I can have tails, tails. 4 total. I need y'all to pay attention. Combos. If Jenna flips the pair of coins 60 times. Okay, ladies and gentlemen, I need your conversations to end. That way we can get more work done. I promise you, you do more when you're focused. How many times would she expect both coins to land on heads? I want both to land on heads. So how many times do I start with total here? 4. Okay, I wrote it down. How many times are they asking me about? 60. So what do I need to make? I'm sorry. Let's go back to your notes and read them. Probability conclusion. So we're wrapping up probability. When you see a question that involves making a prediction, consider the 3 P's. Making predictions in probability involves a proportion. The totals go at the bottom. That's why I wrote that proportion there. Remember, when you see a percent of a population, convert it to a decimal, then multiply by the given quantity. Be careful, you may be asked for the complement. So that's what is not. Here, do they give us a percent? No, so we're making a prediction. If she's flipping 60 times, what can we expect her to get? Is she actually going to run the experiment? No, but we're going to assume that this is what's going to happen based off what can happen out of the 4. So make a proportion. I need everyone to be focused. If it is not for my class, put it up. Okay. What do I know about heads landing on heads twice? How many times can it occur over here? 1/4. Good. Put that in your proportion. 1 out of 4. Total goes at the bottom. Then what's the total that they're inquiring about?
60.
So where does it go?
On the bottom.
It goes on the bottom as well.
X is on top.
X on top. 2 ways to do this. I can cross multiply and divide, or I can figure out how to get from 4 to 60. Both ways will get us the same answer.
15.
What's 60 times 1?
Wait, what was the question?
What's 60 times 1
60.
divided by 4? 60 divided by 4 is 15. Okay, there's my answer. Next question. Use the info to answer questions 2 and 3. The table shows all the possible outcomes of rolling 2 dice. How many possible outcomes are here total?
36.
Good, what'd you do? 36 total outcomes. Okay, now I can answer some questions. If Jerome were to roll 2 dice 48 times, this is another total. About how many times can he expect to roll doubles? So how many times can he expect to roll doubles in this chart? 6. What are doubles? 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and 6, 6. So he can expect to roll doubles 6 times out of what?
Out of 36.
Out of 36 times. What can I do with that fraction?
Divide.
What do I do with fractions?
Convert into a...
Convert, or what's that S word? Simplify. What is this when I simplify? Because I don't want to convert this. 1/6. Now, I'm going to put this 1/6 in a what? Yes, ma'am, a proportion. 1/6. 6 is my new total because it's reduced. And then what's the total that they're asking me about?
40.
What's the total?
48.
48. How do I get from 6 to 48? And whatever I do to the bottom? So what goes here?
8.
8. Great. Okay, number 3. After rolling the dice 10 times simultaneously, Jerome recorded that 20% of the time he rolls pairs that included at least 1 6. Stop right there. What happens in those 10 times?
And he rolls 2 dice.
And then what are the results?
20% of the time he rolls here.
Yep, 20% of the time he'll roll pairs that have a 6. So I know about that 10 times, correct? Cool. Based on his results, if Jerome were to roll the dice 65 more times, how many pairs could he predict will contain at least 1 6? What did I say to do if you have a percent? Go back to your notes.
Convert.
Good. Convert it, then what?
Multiply by who would give you 20.
Okay. What is the quantity that they have given me? I already know about the 10 times. 20% is my percent, and then what am I multiplying? What do I not know about? Pay attention.
How many pairs can you predict?
What do I not know? How many pairs he could predict out of how many?
1 6.
No, how many times? Not 1 6.
30.
The 65. That's what they gave me. So what do I do with 20% and 65?
Divide.
You just wrote it in your notes. I just showed it on the screen. Multiply. What times what? 65 times 0.2. It's got to be in a decimal form. 2 times 5?
10.
Carry the 1. 2 times 6 plus 1.
13.
Where does my decimal go?
13. Between 3 and 0.
How many times can he predict that he'll get a pair that contains at least 1 6? 13 times. Okay? The spinner is spun 72 times. I need y'all to stay focused. What is the theoretical probability? What should happen? I should spin a 1 how many times?
10.
No.
6. 1 6.
1 out of 6. Okay? Or in this case, how many out of 72?
10.
It's not 60. It's 6 to 72.
9 times. 9 times. Wow.
6 times what gives me 72? 12. So 12 times each. Okay? That is theoretical. That's what should happen. Here's what did happen. This is experimental. Okay? Wham. They spun a 1 10 times, a 2 9 times, a 3 11 times, a 4 14 times, a 5 16 times, and a 6 12 times. So only one of these matched the theoretical probability. If I were to simplify this 12 out of 72, what would it be as a fraction?
It would be a 6.
1 6. Yes. If I were to simplify this 16 out of 72, and 14 out of 72, and 11 out of 72, and 9 out of 72, and 10 out of 72,
It would not match.
I need to know what they get. Of course they're not going to match, but I need to know experimental and theoretical here because it's going to ask me about both. So, what is 10 70-seconds reduced? What goes into 10, and guys, these are fractions. 10 over 72. How can I reduce that to be smaller so that I can work with those numbers a little bit faster?
5 over 36.
5 over 36. Thank you. You cut each one in half. 9 70 seconds.
Cut it in 3.
No, bigger.
4.
Bigger.
5.
Bigger.
7.
Bigger.
10, 9,
Smaller.
3, 9, 9, 8.
Can 8 go into 9 evenly?
No, is it 9?
9.
I guess
So what do you get?
Yeah.
1 over what? You better not, hey Siri. 11 70 seconds. Is that simple? Yes, because 11 is prime. I shouldn't have put an equal sign here. 14 70 seconds. What goes into those? Guys, don't be surprised if you see a reducing fractions pathway on TTM, because we need to be a little bit sharper with them. I can look at 14 70 seconds and know that that can be reduced. Pardon? Yes, 7 over 36. Somebody's already ahead of me. 16 over 72. Smaller. 8 goes into 16 and 72. Good, 2 9. Okay, now I have these smaller fractions. They're a little bit easier to deal with. So here, which of the following statements is true? Out of 180 spins, the experimental data predicts the spinner will land on 1 25 times. So experimental, this is where I'm looking. How many times did it land on 1? 5 out of 36. And what are they telling me it should be if I spin it more? 25 over 180. 5 out of 36 and 25 over 180. Guys, what is the proportion? Not just one. 2 fractions that are what? Equal. So, how do I determine if these are equal? Multiply how?
I said.
Cross multiply. You don't have to divide here because I have both of these, or I have all 4 spots filled out. So I need to multiply 180 times 5 and see if it's equal to 36 times 25. Is this true or not? Then go on to letter G. This says theoretical. I'll come back and do the multiplication later. This says theoretical probability shows that out of 216 spins, the spinner should land on 4 39 times. So let's go back to theoretical probability. What should it be? 1 6. And then who goes on the right? 39 out of 216. For letter H, experimental probability for landing on a 5 should be 42 out of 252. What do I write here for the 5? Experimental probability. What do they get? How much? 2 9. And what did they say it should be if I spin 252 times? 42 over 252. Tell me what to put here on this last one. Stay focused. You guys should be writing this down as well. 18 out of 144. And it's theoretical. 1 6 on the other side. So what am I doing to each one? Cross multiply and check to see if they're equal. Cross multiply and check to see if they're equal, just like I did right here. Get her done.
Get her done.